Hi. In this video, let us see a problem in two-way ANOVA here, but there is some small difference because more than one observation per cell we are going to see. See this problem. The following data refers to salary packages in lakhs offered to MBA graduates with different specialization and having studied in 4 different business schools. For the sake of simplification, only 2 students are taken for each interaction between the institute and field of specialization. Test the hypothesis whether the difference between pay packages offered can be attributed to chance at 5%. So we are going to keep the null hypothesis that average pay packages by all specializations are equal and average pay packages of 12 interactions are also equal. Let me write the hypothesis. So I have written the hypothesis. This is the first hypothesis, that is the average pay packages of all specialization are equal, and the second one is average pay packages of all 12 interactions are equal. So here 12 interactions, I am talking about interaction between this, because we are taking for 2 students. In marketing itself, this is for student 1 and this is for student 2. Similarly, finance against student 1 and 2. Operations against student 1 and 2. So, if we compare this, we have 12 interactions. So, we are talking about this, and these all A, B, C, D are nothing but your business school. So, it is in the common category. So, this A, B, C, D are different types of schools, and we have marketing, finance, operations. So, we are going to compare the school wise and the specialization wise. And we have like more than one cell in the observation. Okay, so calculation is like similar to two-way ANOVA. We are going to add all the entries. 6 plus 5 plus 7 plus 6 plus 8 plus 7. This gives 39. Similarly, add all the column wise. So 6 plus 4, 10, then 7 plus 5, then plus 5 plus 5, 20, 32 you will get. So if you add this. Again here, 8, 6, 6, 7, 10, 9. If you add all these things, you will get 46. And the last column, again, if you add, you will get 46. When you add these 3, 39, 32, 46, 46, when you add this, your total is 163. So this is your T. Same as two-way ANOVA. And here if you see, these 2 rows are there, right? So this is for both marketing. So we can add all these things together. Let me choose another color. So 6 plus 5 plus 4 plus 5 plus 8 plus 6 plus 6 plus 4. All these things together is 44. I'm writing here. Similarly, I am adding 7 plus 6 plus 6 plus 7 plus 6 plus 7. So you can add it very easily because 3 times 6 plus 3 times 7 plus 9 plus 8. This will give you 56. So same way you are having the last one 8, 7, 5, 5, 10, 9, 9, 10. This gives you 63. So now we have the total, and if you add 44 plus 56 plus 63, you will get 163. So this is your total. So how you will find the correction factor? Let me write the correction factor here. Correction factor is always T square by N. That is 160 the whole square by the number of values given. How many values are given? 24 individual values are given. So if you notice in each row, 1, 2, 3, 4. Like this, how many rows are there? 6 rows are there. This is row 1, 2, 3, 4, 5, 6. So 6, 4, 7, 24 values are here. So 1107.04. This is your correction factor. Again, as I said in the previous one, if the numbers are too big, then you can take a deviation value and reduce it. For example, first value is 36, second value is 35 instead of this. So, you will subtract everything minus 30 and you will write down the values. Here all the values are already small, so we are calculating as it is. Otherwise, your numbers will be too huge. So, now this is done. As usual, we are going to calculate SSC and then SSR and all those things. SSC. This is for column wise. Column wise, first column what you got? 39, right? 39 the whole square. divided by plus 32 the whole square divided by, why I am leaving some space means how many values we are going to divide will be your confusion. Okay. So now for each column, how many values are there in the table? If you notice each column, for example, you are taking column 1 which contains, what is column 1? That is school A. School A is column 1. How many values are there? 1, 2, 3, 4, 5, 6 values are there in each column. So you are calculating column, you are writing 6, 6, 6. Okay. So this is your SSC, and then minus, what is the formula always? This minus correction factor. So you have to calculate this, and this value is supposed to be 22.4 is your SSC. Please be careful with the calculations to avoid silly mistakes. Now we are going to calculate SSR. So SSR means what you will write? The row total that you got, right? What are the row totals? 44, 56 and 63. Okay, 44 the whole square plus 56 the whole square plus 63 the whole square divided by what is the question? Each row, how many values are there? 1, 2, 3, 4, 5, 6, 7, 8. So you are going to divide it by 8. So it is 44 the whole square by 8 plus 56 the whole square by 8 plus 63 the whole square by 8, all these things minus your correction factor. So what is your correction factor? Just now you have calculated 1107.04. This is 1107.04. So your SSR is nothing but 23.09. So please be careful with this. 8 values are given in each row. That is why I am dividing it by 8. Here 6 values in each column. Don't get confused. So your previous two-way ANOVA video has same number of values in rows and columns. So you will be dividing it by the same number. In this problem it's different. So now SSC and SSR we have done. And SST is total sum squares. Correct? So what you will do? Total sum of squares. So what you will do, you will square each and every element in the table, and then you will divide it by, you will subtract it by the correction factor. So what are the values? That is 6 square plus 4 square plus 8 square plus 6 square. You will write down all the values. Okay, let me write down the values. So I have written all the values. So 6 square plus 4 square plus 8 square plus 6 square plus 5 square plus 5 square plus 6 square plus 4 square. These contains the first row till here, the first row. And then second row starts from 7 square, and then 7 square is the first value and 8 square is the last value. So this is from here to here your second row starts. And your third row values from 8 square to 10 square. I have written all these things. So here 8 square to 10 square, and please don't forget this minus correction factor. So what you will do, you will square all these things and then you will subtract it with the correction factor that we have calculated, and this happened to be 71.96. So what is the difference between two-way ANOVA and this one? We have one more thing. I am going to compare within the sample itself. Normally if you see marketing, only one row will be there. So now I am going to find the interaction within the sample also. So this I will write it as SSW, which is the interaction sum of squares within the samples. Now when you see the values here, we have 6 and 5. So what is the average of 6 and 5? Average of 6 and 5 is 6 plus 5 by 2, which is nothing but 5.5. So you will write 6 minus 5.5 the whole square plus 5 minus 5.5 the whole square. 6 minus 5.5 the whole square plus 5 minus 5.5 the whole square. Plus, if you check the second one, average of 4 and 5, now I have to check. Like this you have to write for all. 4 and 5 average is 4.5. So I will write plus 4 minus 4.5 the whole square plus 5 minus 4.5 the whole square. And again the next one, average of 6 and 8, which is nothing but 6 plus 8 is 7. 8 minus 7 the whole square plus 8 minus 7 the whole square, this is a bracket, plus 6 minus 7 the whole square, plus one more value is there in that is average of 6 and 4. Average of 6 and 4 is 6. So I will write it as 6 minus 5 the whole square plus 4 minus 5 the whole square. I have done it for one row. Similarly, you have to write for all the 3 rows. Let me write all the values, and meanwhile you also calculate by yourself. And in the second row you have always 6 and 7. So you can write 3 into also, because 6 and 7, these two also 6.5, 6.5, 6.5. So instead of writing 3 times, you can write 3 into and you can write it only once. So I have written 3 times. And then the last value is 9 and 8. So 9 minus 8.5 the whole square. Similarly, we are there in the last row. If you want, you can write here 2 times. And this one is average is 5. So 5 minus 5 minus 5. So this value will become 0. So no need to write. Last value we will get only 3 values. Let me write. So I have written this, and twice this 9 and 10 is coming, right? So this is 8 minus 7.5 the whole square plus 7 minus 7.5 the whole square. This will become 0. This is same, right? So I have written 2 times into. So don't get scared of these calculations. If you just check the difference. So whatever the difference is there, 1.5, like that. How many times 1.5 came? How many times 0.5 came? So you can calculate once and then multiply by that number. So this value is 8.5. So your SSW is also there. So finally, what is left? We have to find SSE we have to find. So SSE is equal to SST minus. Remember, in one-way ANOVA only SSC will come. Two-way ANOVA SSR will come. So now within the sample also include SSW also. So we finally get 17.73. Now we have to go for the tabular column. And this is your source of variation between column, which is, this is nothing but SSC we calculated, and this is SSR, and the 17.73 is SSE, and this is SSW. These are the values we have calculated. And degrees of freedom, the first one is number of columns minus 1, which is 3. We have 3 columns, and number of rows minus 1, 3 rows 2. So this is your VC and this is your VR, and your V is multiplication of this, 3 2s are 6, and your the degrees of freedom that you take for V2, you have to be very careful. How many interactions we have? 24 interactions. So you have to write n minus 1. 23 minus this above minus 3 minus 2 minus 6. So this 24 interactions we have. In the beginning itself I said 24 values are given, right? So this is n minus 1. And this is this C minus 1. And this is R minus 1. Already we have calculated. And this is your V. After writing all those things, mean sum of squares, always we will divide the values by the degrees of freedom. So we are dividing this 22.04 divided by 3, because this is from here. Column minus 1, how many columns we have? Schools, 4 schools we have. A, B, C, D. 4 columns we have. So 4 minus 1, which is 3. That we are solving it. 22.44 by 3 gives 7.48, and 23.09 divided by 2 gives 11.55, and same way 17.73 divided by 6, I'll directly write the answer 2.95, and the last one is 8.5 divided by this. What is this value? 23 minus 6, minus 3 minus 2, 6 is nothing but 12. So the last column is 8.5 divided by 12, which is 0.71. So now we have to calculate our F ratio. So 7.48 divided by 0.71. This value we have to calculate. This is nothing but 10.55. Similarly, I'll write the other values. So I have written all the 3 values. So now you have to compare this with the F ratio value from the tabular column for the corresponding degrees of freedom. Now these are the table values at 3, 12, that is V1, V2. What is the first value? This 3 is here and 12 is here. 3, 12 is 3.49. So this is for the column wise. So you have to compare this with the column wise result. So 10.55 is greater than 3.49. Therefore, what we will do? We will reject the hypothesis. Reject the hypothesis. Similarly, this is from the second table for V12, for V212, the value is 3.88. What we got is 16.26. 16.26 is greater than 3.88. So again, what we will do? We will reject the null hypothesis H0. And then finally, from the table, again this combo. So 312 combo we have seen. Then for the row 212 combo, that is why we are checking with the row value. And within the sample also we have this 12. That is what we are checking. What is the last combination? 6 and 12. So 6 and 12 value is 3. And what is the value we have got? 4.15 is greater than 3. Again we will reject the null hypothesis H0. So what is the null hypothesis? There is no difference between the samples row wise, column wise, no difference between row and column, and within sample also. So in all three cases we reject the hypothesis. For example, if it is less than, then in that case we will accept only the particular value. Thank you.